All right, welcome back. Happy Monday morning or Monday afternoon, whenever you're watching this. We have another big lesson to get through, okay? It's not that hard. It's kind of strange not having you here with me to explain it. Lesson 32, an antiderivative, okay? Now, it's not that big of a deal. I have a question for you first, though. Opposite operations or inverse operations, right? You know the inverse for addition is what? Subtraction. What about multiplication? That's right, it's division. What about squares? If something is squared, what do? We take the square root. All of these pieces are inverse operations, okay? The inverse operation of subtraction would be addition. Division would be multiplication. Square root, we would just square it, right? There, we can go back and forth. One undoes the other, okay? So let's think about that as we have been doing and finding derivatives, okay? So a derivative, okay, I like examples, you know that. So if we wanted to find the derivative, let's say let's start kind of nice, x squared. What's the derivative of x squared? 2x, you all said that. What about the derivative of, this is a hard one, e to the x? We would say it is e to the x, right. What about natural log x? What's the derivative? 1 over x. I'm kind of going through these same ones that we reviewed last week, just so they're in our brain again. So the derivative of sine x is cosine x. What about cosine x? What's the derivative of cosine x? Don't forget that negative. Okay. So now we have all these pieces that we know the derivative of, okay? So the question is, can I have an inverse operation, an antiderivative? Okay, so if I give you 2x, what's the antiderivative? X squared. What about e to the x? What's the antiderivative? E to the x. What about 1 over x? What's the antiderivative? Natural log x. What's the antiderivative of cosine x? It would be sine x. What's the antiderivative of sine x? It would be cosine x. So we're just going the opposite direction. Okay? Now, there's some tricky pieces. Let's don't say tricky, that's a bad word. There's some little hiccups that might get us. Okay? So if I give you something that's a y equals x squared plus 12. Okay, let's say that. What is the derivative? What is y prime? Okay, we know if there's an addition, we just take the derivative of both pieces. So the derivative of x squared is simply 2x. What's the derivative of 12? Remember, it's a constant. Constants have no slope, so it's 0. Okay? Well, let me give you a different one. What if I say y equals x squared plus 572? Right? What is the derivative of, or y prime of x squared plus 572? You're all saying, yeah, the sevens, it's the same thing. Right? Oh, can I do one more? One more. I know I don't have a lot of room. Y equals x squared minus, let's say 7. What is that derivative? What is y prime? Do you see that all of these functions, all of these y functions have the exact same derivative? All of these y primes all have a derivative of 2x. Okay, so it's not quite as simple as, hey, x squared, the derivative of x squared is 2x. Okay, going backwards, we know the derivative is 2x. Which function did it come from? Okay, which function did it come from? So this book will say, I like the black words, the bolded words, no single function is the antiderivative of 2x, because there are infinitely many functions whose derivative is 2x. Okay? So going backwards, given 2x, going backwards to find the function, we don't know which constant it is. Okay? So we would simply say, and sometimes they put a big F, the antiderivative or anti-differentiation, we'll talk about differentials and differentiation in a little bit, would simply be x squared plus some constant that we don't know, where c is just some number, okay? So the antiderivative of 2x would simply be x squared plus c. Would that fall and have all of our f of x's up here, or our y's? Yes. So they do a general form. All right. Now, the fact, I like some of these definitions, I actually like them. An indefinite integration. So this is all the same thing. There's just lots of different words for it. We won't talk about an antiderivative very much. We're going to talk about an integral, okay? And at the top of page 174 is a much better explanation of one to the other, okay? An indefinite integral or integration, okay? Let me write the way they do in the book. Is the process of finding the set of all antiderivatives of a given function. Okay, that is indefinite integration. Okay, we call the set of numbers is called the indefinite integral. It is incorrect to speak of the antiderivative of a function because there are more than one, but it's correct to speak of the indefinite integration of indefinite integral of a function. Okay, we'll use this symbol. It's an elongated S. Okay, that means the integral. That's the integral symbol. Okay, to indicate the process to find the indefinite integral of a function. Okay, we can say the integral of 2x dx. We're going to use the dx because that's the variable that we're taking the derivative of. Okay, that we have taken the derivative of. Okay, dx indicates the x. The x is the variable of integration that we're integrating with respect to x. Okay, so the integral of 2x dx is simply x squared plus c. Okay, there is no exact science to this. They talk about the definition of a derivative. It's how you get it. But there's no corresponding definition of the indefinite integral of a function. Finding the indefinite integral of a function requires the ability to guess and check based on your experience with derivatives. Okay? So guess and check. This is what it is. And that's pretty much what we're going to do. So, but we have to know that we have to know all those derivatives. It's like you can't do division unless you know all your multiplication facts, right? And I'm going to tell you the truth. I'm going to scroll as I'm saying this. I don't use the word indefinite very much. I'm just going to say integral. The integral of 2x dx. Okay? So here let's do some examples. Technically that was our first example. Can you find the integral of cosine x dx? Okay? What function gives, when I take the derivative of it, gives me cosine x? Okay? Well, it can only be sine or cosine. Sine x. Okay? So then we're going to check what's the derivative of sine x with respect to x. The derivative of sine x is cosine x. That works. So going backwards, it would work. Now, what did I forget? Could there be a constant out there with sine? Like a plus 12? Yes, there could be. So we always have to put this plus c, that constant of integration. Okay? So we've guessed, we've checked, we're correct. Okay? Let's do another one. What about the integral of negative sine x dx? Okay? So what function's derivative gives me negative sine x? We just put them on the other page. Of course, it's cosine x. Right, don't forget your constant. Do we need to check? What's the derivative of cosine x plus 8 dx? I always put the constant, it helps me not forget. So what's the derivative of cosine? It's negative sine. What's the derivative of 8? It's a big fat 0. Okay? Well, you're correct. Okay? I'm going to go to the next page and we'll look at a few more. What's the integral of e to the x dx? Yeah, whose derivative gives me e to the x? It's e to the x plus your constant c. Okay? Now here they worded a little different. It means the same thing. Let dy dx equal cosine x. So the derivative of some y equals cosine x. And I say find y. So we know the derivative of some function y equals cosine x. Whose derivative of cosine x? Correct, it's sine x. Don't forget the plus c. So is the derivative of sine simply cosine? Yes, it is. And that's it. That's all this lesson is. We will jump into a lot more later, but this is just a good introduction to this. I am going to go ahead and do one of your homework problems, 1 or 2, with you. So we're going to start at number 3. Okay, well, let me go ahead and write what it is. So we're going to do lesson 32. We're going to do numbers 3 through 14. Okay, 3 through 14. That will be due a little bit later. We're not going to have to. You don't have to do all of them today, but I would definitely start working on them. Okay, let's look at number 3 together. Okay, find an antiderivative of each expression in 3 and 4 with respect to the variable in the problem. So it's kind of like you're just guessing what antiderivative, what function would give me a derivative of 5x raised to the 4. Okay? And it says and. So another way to word this problem would be integral of 5x to the 4th dx. But this one just wants to find one, and, any one, okay? So we don't know the quick trick secret, but this 5 and that 4 kind of remind me of something, right? I hope it reminds you of something like x to the 5th. If we bring down the 5 and subtract 1, does that give me 5x to the 4th? Yes, it does. And when they say and, you can leave it like that. Or you can put x to the 5th minus 2. Or x to the 5th plus 12. I don't know why I've said 12 so many times. But just, you can put anything like right there that you want. It's just kind of like that guess. Okay? So don't worry about that. Here we go. I think you're good. So I think I'm going to go ahead and stop. I probably hit a good time. Keep watching, keep asking questions, and I will talk to you later. Happy Monday. Bye.